Okay, good morning, everyone. Okay, so you can see by the title, I'm not the most imaginative critter out there. But what we're going to be doing is talking a little bit about trees, and a little bit about porous pavement, and then how we can put trees and pavement and stormwater into a common equation. And so the first part we're going to do is look at some of the resources available. Anybody see the Princess Bride movie?
Yes.
Okay, you remember he wakes up after being mostly dead all day, about to attack the castle, and the first thing you have to know is what equipment you have available to you. And so here's some free downloads. There was a design shred a Forest Service put on, and there's actually a 3-part series of documents that are on free download, looking at how you can look at forestry within stormwater in a watershed. And there's some very interesting good ideas. There's also some things that I know cannot possibly work. So you need to read these with a critical eye, but there's some very good ideas and maybe some things that can help you connect some of the dots for the things that you're hearing today. We talk about urban trees because they provide environmental services. Okay, and that's important. You know, we talk about water. We can talk about the roots stabilizing soils on embankments. We can talk about carbon sequestration. We can talk about 1 million trees in New York City back in the late 80s, early 90s, when they said to meet the state implementation plan for ozone reduction in New York City, it takes somewhere around 1 million trees to come into compliance. And then the Forest Service followed it up with a study and saying, you know, we could fit 1 million trees in New York City. New York City, while the number is unreasonable, and I agree with everything that was said, that's the only 1 million tree initiative that has any underpinnings with an understanding of what can be done and where is there some space. Of course, the whole soils thing devolves, and there are a lot of supply chain issues. Okay, but we know that they can do things, and although I have the aesthetic sense of a dead sheep, there are some people that are very good with design, and trees can provide useful aesthetic and amenity services. But what really counts is we know that if we have a good landscape and it's halfway well maintained, people will drive further, will pay to park, and pay 10 to 15% more per convenience item if there's a good landscape. So it means money if you do it well. And it means less money if you don't do it so well. And we know that consumer behavior can be changed in parking. We know that if they park in the shade, efflux of volatiles, such as gas off of tanks in a hot parking lot, go down if there's some shade. So there's very useful things, and we can get LEED certification points and all sorts of gold stars and the occasional cookie at a conference if we do the right thing. Okay, so what we're going to be talking about is porous pavement or pervious pavement. So we have a wearing surface on the top in the darker color. We have a base course material that is compacted to support that wearing surface under a traffic load. But of course that's useless unless you have something underneath that supports that base. And you know, we're always talking about how good porous pavement is, and it can work. Although there's some very interesting data that's been coming out of New Zealand where they say the porous pavement makes no difference to the plant or the environment as far as a plant organism unless you have something underneath it can grow in. If you use a standard profile, the plants aren't going to grow because you have to compact these materials to support any kind of pavement. Okay, so they're all very concerned that porous pavement isn't stacking up. What they forgot is that this is a multi-layered engineering system, and you have to take care of the engineering with reference to the biology. And so if we're going to support a pavement, we need to make sure that what we're planting in has some viability as well as some ability for engineering support. And there are a lot of materials out there. This is one project from Cornell. I always have to spit when I say Cornell. It's just something I'm great. You know, the fact is when they get in trouble, they call Rutgers. So what we have here is a pedestrian thoroughfare where all of the books to their bookstore go up and down during some of the worst loading periods after frost heave in the spring. And what we have is intercepted flow in these openings, but we have a biologically designed material supporting the pavement from side to side. And so what we can do is take the sheet flow, intercept it, and drive it below ground with a porous pavement. Capture that water and then use the trees to de-water the system through transpirational demand. Okay, so it can work. That was installed, I believe, 1994. I was there with the construction engineers, and this was the first time we translated the research in New York into practice. There are some products that are over in Europe. I know that in Holland, the Amsterdam tree soil has been out there for over 20 years. There are a lot of different design soils. The point is, you need to know your traffic, you need to know your wearing surface, and then you design your material. And again, you can actually see where some slightly balding Pollock has actually written chapters and shown how this can be done in different books. VTech, yeah, you gotta believe VTech. They also, whenever they have a problem, they call us truckers. When they do, they come out with these things about trees and structural soils. This is another very nice free download that gives you some information. There's a lot more information if you go to the stormwater management site. And you can see that they actually remember to put Rutgers into the monikers of all those things down at the bottom, because when it comes to the details, they call folks like Chris Abrupta. They do good work when they have Rutgers helping them. Also Cornell. Cornell has some very nice free downloads where you can look for some technical specifications and find some of this information as well, specific to porous asphalt and CU soil. Okay. These products, usually they build a load-bearing material out of a coarse aggregate, and in between those coarse aggregates, we put the horticultural component. And the ratio blending really has more to do with the engineering than it does with the biology. Here we have an 80% stone. I believe it's an ash stone number 4. But in any case, it's about 1.5 inch to 1 inch size aggregate, 80% by weight with 20% by weight of a clay loam soil. Amaret Corporation does hydrogels. They stabilize the material with hydrogel in this case. And here we're compacting the material, and then we're going to put some turf over that. And now we have what is considered a green parking lot, because all of the water, when they wash their cars, they have no splash because it's going onto grass. And all the water gets driven down and is de-watered by the transpiration of the grass. And they have preferred customer behavior because they sell many more cars when you're walking on the grass. And it's designed to take that level of traffic load. So you can sell cars, you can have what is technically a zero stormwater runoff here. And you could even put a little bit more water into that coming off of some of the sealed surfaces. This is one of our memorials in Washington, D.C. There's a landscape architect out of the Princeton area and operating in New York called Henry Arnold. He has some very good design soil materials. And in this case, they're compacting it. They put some trees in with some unit pavers. And they established trees for a rather heavily used pedestrian area, being a major national memorial. I tend to think that when we're talking about cars and things, I like the permeable pavers that are the interlocking, what we call porous interlocking concrete pavers. We know they move. But we also know if we have plant material on the sides and roots underneath, they move upward in a more consistent manner that doesn't destroy the surface. So I kind of like the concrete stuff. I do like the asphalt stuff. I have equal opportunity as long as we know what we're doing, we know what to expect as far as the riffling or the displacement of these surfaces. And what we can do is take sheet flow off of the edge, drive it underneath, hold it. We can de-water it off of the side. We don't have to support the pavement with a horticultural soil if we don't want to, although it does allow you an effective use of space. So there's a lot of different things we can do here. We can use a porous asphalt. One problem I've seen with porous asphalt, it can very easily be maintained. People say it plugs. I haven't seen that much of that. As a matter of fact, I think that is Well, quick joke, how many academics does it take to change a light bulb? Change? Can't have change. And so I think that sometimes engineers fall into that as well. Why are we using this material? It forces Team Porsche to use everybody else's tires on the Grand Prix circuit. We've been using these materials with great effect on all of the runways in our airports for years and years and years. We know it works. The problem is if you turn wheels on it, it really has a negative effect on the wearing surface. So you want to put this material in where the wheels are staying straight. And you have to communicate to the DPW that you don't need to seal this because it looks different than this. And that, folks, is a problem. The communications problem is what we really have to address here. Well, we've been doing this for years and years and years, and it seems to work quite well. It's not a new product. Designing the soils underneath is a little bit of an issue. We're still trying to come up with proactive ways of giving our best designs to meet engineering and horticultural needs. I think that if we look at the old way of voids analysis for Marshall asphalt concrete design, if we put a couple biological indicators in the voids analysis, I think we have a tool. I just have to find a graduate student stupid enough to try to work with me. There are people that are working on that from Denmark, down in VTech, you haven't given me VTech, Clemson, which they're not curious, we can let them go. They also call us when there's a problem. Here we have Singapore. There's a lot of people working on these products now. We know that they work at this point. As far as design soils, we can design for engineering and biology at the same time, and they can support sealed or porous wearing surfaces. We can even come up with cantilevered designs to hold the pavement over a non-compacted regular agricultural soil. A very expensive option, but a very viable option if you've got that kind of money. And this is just one of several projects looking at different materials out there. But that cantilevering, we're getting a little bit cagier with it, and we're building modular designs. This is Storm Tank. I don't know if anybody's seen Storm Tank. What's nice is that it also goes into like a HydroCAD program applet. But here the water goes into this solid structure, and it's got a 90% void space, actually 97% void space. It will support your base for your wearing surface and support a porous pavement. You could also put a soil and support vegetation. But the vegetation component is separated from that water. There's a discontinuity, so you can't rely on this to transpire all of that water out. But if you can deal with that disconnect, that's very potent to have 97% void space underneath an area like a parking lot and support that traffic loading. It means it's land you don't have to develop for a storm management plan. Okay, and that's valuable. Are we running out of space up here in Jersey City in any particular areas? Yeah, I thought we might be. So this is something to think about. There's another product out there that is just as good support. However, the general idea behind this is that you fill it with soil, and then you plant a tree in an opening and let it grow in natural agricultural soil. Okay, now if you think about your agricultural soils, instead of a 90% porosity, here you would have maybe a 40 to 45%. We don't know all of the details on what soils to specify under here, but I'm pretty sure we can figure that one out. But there is this product. This is, instead of Storm Tank, which I believe is this one, this is called Silvacell because it was designed to establish trees and cantilever pavement around the trees. Okay? I'm pretty sure that if you change that 97% porosity, you could use HydroCAD for one of these systems as well. They just haven't marketed that. If we want to avoid using the plastics, or if we want to go strictly with the pavement design and a designed soil, what we do know is that these materials, the soils themselves after compaction, they can take about 60 centimeters per hour of infiltration with water. They can move water down fast, so it won't limit the ability of your porous pavement to take water in. We know that it behaves after compaction as a clean, well-rated sand. It has about a 25 to 30% volume for voids. We know that it can drain. We figured out how to manage plants in this material. Okay, we also know we can land a 747 on it with zero deflection after compaction. We know it will support pavement. But what we could do then is we could, instead of saying having a parking lot intercepting sheet flow and then having the water drain off and support trees, even with that, we know that 25 trees can take a 3-inch stormwater event and dewater it in about 5-6 days. Okay, we could intercept that water and start putting the canopy in the middle of the parking lot with the design soil system. So we actually have that technology now. Of course, trees take time. These trees don't get planted with a 30-foot canopy. So what we have to do is think about, like the previous speaker, how do we stage our vegetation communities to provide uniform service of transpiration to keep dewatering from day one and phase it into the canopy? That's one of the issues that we really have to look at. And we also have to get rid of the whole native thing. There are very few natives to a concrete parking lot. Okay? I mean, it sounds obvious, but I mean, these are contrived design systems. And we know that our environment will be very different 40 years from now when these trees are coming online. So we should be choosing for the biotic aptness of 40 years from now, not from what we had 40 years ago. And that's not good or bad, it's just management. These are design systems. We have to think about that and then worry about the invasive capacity of our choices and make sure that we factor that into the choice. And I know that I'm out of time. Too bad. Wearing surface, we do have a base, and then we have to think about, the biology of the system. But if we encourage root growth under here, we have to be sure we can design those areas above to accommodate that root growth. And we're developing answers, and I'm just going to blast through that very quickly. But we are coming up with answers, and it does seem reasonable that with a normal wearing surface, by adjusting the base from about 9 inches deep to 4 inches deep, we can accommodate radial root growth and displacements of roots without breaking the surface of that pavement. At least that's what the Center of Advanced Infrastructure and Transportation is telling us. I'm a biologist, not an engineer, but the engineers are saying, we can do this now. So I think that you'll find in the next 5 or 6 years we'll have some of these design details out in full. And just remember, trees are complicated, pavement's complicated, but trees and pavement with stormwater is complex. And with that, I'll take it to the next speaker.